Okay, in the last video I showed you this example, which is very visual. Here we can see a EVH motion being classified by a neural network using just two vectors, just the velocity from the hips at the latest instant and also at a third of a second past. And then we use that to classify the motion in between four different types of locomotion, which are idle, walk, running, or jumping, right? And for this we use a pattern net. Here we have the compound. We can dive in and see the actual topology of the network. You'll see it matches the topology we see inside MATLAB. This is very nice and visual, but how do we actually move the data, the setup, the topology from one package to the other? I'm gonna show this from the beginning. So I'm gonna start here a new session of MATLAB and use the neural network toolbox to create a very simple neural network. I'm gonna use it right here, and I'm gonna load one of the examples. I'm going to use the engine example because it has only two scalar values for training, so it's simple to recreate. It's just easier to visualize. It actually doesn't change much the processes we need to do. But here we go. Now we're setting up the network, how many neurons we want in the hidden layer, and let's just train it all. Okay, train. I'm not gonna explain any of this, alright? I assume you have a little background on how this works. So I'm just gonna save these results and finish. Alright, I'm gonna close all this. So here's my network. Okay, I can view it, and basically I have two inputs, 10 neurons, and then two outputs. Okay, and my hidden layer has a tangent hyperbolic function, and the output layer is a pure linear function. Okay, so we need to transfer all this information to Fabric Engine. The number of layers, kind of functions we have in here, and also the weights, the W's here, the weights between layers. So this W, then we have the bias function, the bias weights right here and here. And then we also have to transfer the processing function. So these networks have a processing function on the input and in the output. Okay, we can see this if we just write like net and then inputs, and then we're going to check the first input. We're going to see it has a map min max function. So the data is squashed before it gets inside the network, and then it gets unsquashed when it gets out the network. Okay, so we're going to reproduce all this topology, and then move the data from one package to the other. Here in Fabric Engine, we have the extension already loaded, and you can dive in and see what actually makes the network object, the layer object, and all that. But I have created some compounds that make all this easy. Okay, so you can go dive right here into compounds, and you're gonna have a input compound, a hidden layer compound, and a output compound. So you can basically just create as many hidden layers as you want and daisy chain this, stack this network. So you could do, in theory, you could do deep neural networks if you want. We don't have more advanced topologies like time delayed topologies or convolutional topologies, but this kind of basic deep topology you could do. And then we would simulate this network using the feed forward node. Okay, and then you can double click any of these And here you're going to have the transfer function. So here, tangential function is the same one we have for our network here. I think I actually have it here. So this is the tangential function. And you could have a sigmoid function or a softmax function if you're using a pattern recognition map, like the one I showed you before. Okay, so you could create the topology yourself. It's very easy, and then you would load the weights in here. Okay, so you're just going to copy the topology we have there, which is one hidden layer and one output layer. And we have the 2 inputs, 10 neurons, and 2 outputs. So 2 neuron inputs, and then 10 hidden units here, and then 2 outputs right here, and pure linking. And then for loading the weights, these weights, they are matrices in MATLAB. So you could do like this to see the, for example, the input weights 1. They're matrices, they have columns and rows. So you'd have to, in here, we have to use the matrix and load it from a CSV file, right? And to export this is very easy. Just do a DLM, right? You're just gonna write it as a CSV file, and you do like hidden weights 1, or hidden weights just .txt and so on. Yep. Okay, there's one extra end right here. So now I have my hidden weights right here, and I could load this right now. Just double clicking this, find it in my computer right here. If I want to see if this is correct, I can report it. And there we see it's correct. Okay, so I then load this here. Now I have to do the same for the bias, the output weights, and the bias weights. So I just pause the video and I'm gonna export all the data. Okay, so my network is complete. That's all I need to do to set up. And then, as I told you, I have processing functions in inputs and outputs. So I need to get the parameters for this. I'm gonna grab this again, do process settings. And in here, I have the minimums and maximums for each of my features. Okay, so I'm gonna save those. I'm gonna get the X min and save it. Oops. And I'm gonna do the same for the max and then for the outputs, and then I'm gonna pause the video and I'll come back. The data I need here, and then I'm gonna get the same processing function we have here, which is the min max. Getting here the functions min max. I'm gonna connect this to the input and the max output right here. So it's important that we have the input and the output, because the output map min max is actually the reverse of the input. Okay, so that's important. And since these are not matrices, they have only one column, we use the array from CSV. All right, you can use the math from CSV. This port is dynamic, so it will work either way. But just for the sake of it, we're going to use this one. And I'm going to get here the X max min, and then the X max, and so on. Okay, so our whole network is set up right now, and now I'm going to get the data from here and check if our inputs and outputs match those of MATLAB. So we have a data sample here with more than 1,000 samples. I'm going to get just the 10 first samples just to show if this is working. So I'm going to get 2 features and the samples 1 through 10. Okay, so actually this is going to be engine inputs. I'm going to make these my first inputs. You can see those. Oh, actually it's incorrect. It's 1 and 2, 1 through 10. Okay, so here we have the features, 10 cases of these two features. And I'm gonna save this also as a matrix. So I'm gonna do another VLN write, inputs, and my first inputs. And I save this, and now I'm gonna load this in MATLAB. And when I'm gonna load it, I should run it through the network, and we should get the same results as if we do this. So these are the results we should get. Okay, so let's see. I'm gonna load another matrix. This time our inputs. And I'm gonna put it right here. So if I report, I should get that same. Let's just check if our inputs are correct. Okay, so right here you can see 17, 35, and so on, which is the same we had right here. And then if we do this, and we're getting wrong output, so there must be something I did incorrect right here. I'm just going to check and think this map min max function, right now it's with the wrong default values right here. It should be remapping to -1 and +1, and the same thing for the output, -1, +1. And now we see we get the same results. I'm gonna just clean this. Let's do it again. Now you see we get the same results we do here in MATLAB. -9, 141, and then in the second line 168, 523, and so on. So 9, 141, 168, 523, and so on. So you see it's if we copy the same values right here, you get the same results. And of course, here in MATLAB, you're gonna post. Okay. In MATLAB, you're gonna use a whole batch of data, series of events in the form of a matrix. But most of the time, what you're gonna use Fabric Engine for is to do stuff in real time. So instead of using a matrix right here, most of the time you're going to just push a array of scalar values. So we could do this, we could do a push, and then we know our network needs 2 features, so I'm going to push two constants right here, 2 scalar values. Okay, another one. Okay, and I'm gonna put this right here. So now if we change these values, we should get the appropriate response from our network in very real time, as you can see. Okay, which is pretty much what we have in the other example. Something else you might want to notice is that here we have created our topology from scratch, but I also created the most common topologies in MATLAB right here. So you have the FitNet, which is basically what we did right here. If we enter this, you're going to see it's the same thing. Then we have the pattern net, which is similar, but the actual transfer functions are different. We have 10 sig and softmax right here, and then we have autoencoders and decoders for a dimensionality reduction. Okay, so if we, for example, if we did this and then just use the same number of neurons right here and connect the weights right here, this, you see, you get pretty much the same results, nothing changes. Delete this, and it's easier to look at, right? So that's the neural network extension in a nutshell, and if you ever use it, please post some comments on it, and if you have any other questions, I'll also help if I can. All right, thank you.